G'day, here's an age-old question. Consider the number 0.9999999 going on forever. Does that equal 1 or does that not equal 1? Now, in a 10-1 machine would be, okay, here's a 10-1 machine, nothing, point, 9 dots, 9 dots, 9 dots, 9 dots, 9 dots. It's a very full machine, at least in the decimal part of the machine. So is that number 1 or is that number not 1? Students of all ages are fascinated by this question, as am I. All right, so how do we think about this? First of all, I need to note that we cheat, meaning we never actually write down the number we're talking about. I wrote down, it was like 10, 12 nines, and I had to go to dot, 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 and ellipsis to say, keep going. I, as a human being, can't actually write down the number I'm talking about. I can't keep going. I can't keep writing an infinite number of nines to the right of the decimal place. So right there's a cheat going on. So it's a mind game. This is something that seems to exist in our minds, and we're asking, if I really could go beyond the end of time and write down an infinite number of nines to the right of the decimal point, is the result of that particular thing equal to 1 or not equal to 1? And it's curious here because we human beings will never see it equal to 1. For example, if I just stop writing after 3 nines, well, I get 0.999. Clearly that's not 1, it's smaller than 1. If I wrote the first 7 nines, 0.9999999, that's still less than 1. Whatever I as a human being can actually have the patience to write down will never equal 1. It'll always be smaller than 1. So that might make you think, oh, if what I always see as a human being, if I wrote down 20 billion nines, would still be shy of the number 1. I will never see 1 as a human. That makes me think maybe the whole number in the end itself is also less than 1. That's a fair enough argument. But then we could do an algebraic argument. For example, if I'm wondering what this particular number is, let's do some mathematics on it. And a very standard algorithm goes as follows. First of all, give it a name. I know, I'll call it F for Frederica. And what many people do to Frederica is they multiply Frederica by 10. Why? What does that do? Well, multiply by 10, so 0.999, everything multiplied by 10 actually then becomes 9.9999999 forever. Which will be, of course, Frederica times 10, 10 Fredericas. Great, so far so good. Now I'm going to subtract these two results. So what I'm going to do is say 9.999 forever, 10 Fredericas, take away 0.999 forever, 1 Frederica, must give me the equation. 9 with a whole bunch of 9s, take away 0 with a whole bunch of 9s. All the 9s after this one cancel. 9.99, take away 0.999, blah, 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 is 10 Fredericas minus 1 Frederica. That is 9 Fredericas. Ah, that tells me Frederica must equal to 1. What was Frederica? It was the number we're talking about. Apparently, 0.99999 forever, according to the mathematics, equals 1. All right, do I believe that? Well, maybe I do actually. If I draw a number line, here's a number line, here's 0, here's 1, it keeps going. What I'm really doing is I first got the number 0.9, okay, if I did 0.9, it's about there, not drawn to scale. The next one would be 0.99, I guess it's there, 0.99, not drawn to scale. Next one on this list would be 0.999, which is there, not drawn to scale. 0.9999 would be even closer. Maybe if I think of it this way, 0.9, 0.99, 0.999, the numbers I see as a human being do seem to be scrunching up to the number 1, which might make me think, okay, it really does equal 1. All right, fair enough. Maybe another way to do it is actually go back to the 10-1 machine. Is there any way I could see this equals 1? Well, what I could do perhaps is, well, I know. What if I put a dot and an anti-dot in here? Dot, anti-dot. That's still technically 9 dots in that box. But then there's an explosion. Kaboom! Messy fingers. There it goes. Kaboom, kapow. Well, just one kaboom. And dot. So now I've got 1, anti-dot, 99999. Oh, but do it again here. Dot, anti-dot. Kapow! Dot. Oh, dot, anti-dot, poof. Annihilation. Do it again here. Dot, anti-dot. Kaboom! Dot. Poof. Oops. Picture's getting very smudgy. Maybe you can follow it. So that's empty. Anti-dot, 9999. Do it again. Dot, anti-dot. Kapow! Dot. Annihilation. Poof. In fact, if I keep doing it, I can see all this is clearing away, and it does seem to equal 1. Okay, so maybe we've now argued that 0.999999999, if I could do this forever, if I could go beyond the end of time and actually write down that number, that number in the end will be equal to 1. Seems totally believable. This seems like an ironclad argument. But here's the thing. If you believe this argument, then you're going to have to also believe what I'm going to do in the next video. Watch out.